record this after. Yeah, starting soon. Alrighty, welcome everyone. So this is our first one-on-one session. So the mornings are going to be fully all mech one-on-one sessions. We're going to have a short list of which ones are presenting real soon. Just as usual, if you guys were at general, just some housekeeping items. Mute yourself before the presentation. Save question answers until the end of every segment. So let's say Dynamics finishes, you have a 5-minute Q&A section, or you can wait until the very end, or send messages on Slack or something. Actually, since we have the chat function and there's a bunch of leads and core in the call right now, feel free to ask questions there, and we'll get someone, or someone might help answer the question. Oh, Kobe, can you turn off the blob that you don't have permission to play one thing?
So sorry, there's a blob or something? Wait.
No, sorry. I mean, in the bottom left corner, there was a banner type of thing when you were in full screen. Yeah, there you go. Thank you. Just for internet provider's sake, and just because not everyone can handle it, just have your videos off today. Maybe if you want to turn it on for questions, but leads and core, if you guys are presenting, please keep your video on, just so people can match face. And lastly, just feel free to use the chat. Next slide. All right, welcome to our onboarding day, session 1 with MEC. Next slide. So this is just a quick kind of overview of what's going to happen today. So you guys don't have to stay for the full thing, but we do encourage you, since this is a full MEC session. So it's going to be dynamics first, structures, boundary blocks, interiors, and those who are looking to join mechanical too. There's actually going to be a mechanical general project announcement, introduction of how this onboarding project is going to work. So that's going to happen at 11:30 at the very end. Next slide. And we'll hand it over to Leif.
Hi, I'm Leif. I'm currently the Dynamics lead. I'm in 3B Tron. So yeah, I'm just gonna kind of briefly overview the Dynamics subsystems. So next slide. Yeah, I'm Leif. Catherine is still our PM, and then Kevin, occasionally we go to for some advice as needed. Next slide. So currently, it may be worth kind of giving an idea of sort of what is the dynamic system to us on the team that sort of comprises 3 subsystems. We have the suspension, steering, and braking systems. Essentially all the things that move in the car, all the mechanical parts that move. So this term, our goal is to assemble all these things together. We have a lot of custom designed parts that have been machined for us. We have a lot of off-the-shelf parts that we've purchased, and all that needs to come together and be assembled into the rolling chassis by the end of term. So what do we have to do? Obviously we have the assembly, and then before that we have still some sort of what we call pre-assembly on-site tasks left to do. There may be some off-site tasks that pop up every now and again, but the bulk of the work is really on-site in putting things together this term. Next slide. So I'm just going to provide now a brief overview of all of the 3 subsystems that I mentioned, starting with suspension. So what is suspension? It's a mechanism that controls the movements of the wheels vertically using linkages and a spring damper. So the spring is there to store temporarily the impact and re-release it, and then the damper takes the energy, the kinetic energy from the bump, and basically transforms that to heat so that your car isn't just bouncing up and down all the time. The top right little animation there, that's not actually MS-14, but it shows a similar operation of how the suspension works. You can see that you have you have sort of these two parallel bars that move up and down. And in this case, this is sort of what's shown here is most likely sort of like a double wishbone. You have these two linkages that are like pointing in towards the inside of the vehicle, and these parallel linkages are moving up and down with the wheel. For us, because of the constraints of our packaging, because we have this catamaran shape to our vehicle, those two arms actually point towards the back. You can kind of see that here in this diagram here on the bottom. So there's this lower arm that points to the back, and then on the top, it's difficult to see really, but there's like a it's called like an A arm or wishbone, and that also points towards the back. So it's sort of everything is kind of turned by 90 degrees, but you still sort of have that sort of parallel motion. And then again, we have a spring damper, although it's a bit more complicated because of packaging constraints. And so there's like this push rod that transfers load, and it gets a bit more complicated. Anyway, why do we need the suspension in the vehicle? Obviously, it makes driving a lot less painful for the drivers and passengers. You're not getting sort of bumps directly translated into the vehicle, but sort of beyond that, it helps the other dynamic systems. You can't steer if your tire is not on the road, and the suspension maximizes the tire contact time with the road, and it also reduces the vibrations from the road, so things aren't shaking about, and that's going to just sort of help everything in the vehicle stay safe, stay together. We can go on to the next slide. So then steering, obviously, the steering is important for obvious reasons, and it just controls the direction of travel of the vehicle. Basically, the steering subsystem that we have is just a long series of linkages of interconnecting arms, and it's quite similar to the animation that's shown in the top right here, and it uses a rack and pinion and then linkages to transform the rotational energy of the steering wheel finally into rotation of the steering wheel into rotation of the wheels themselves. And then the wheels are, the geometry of the steering is calculated in such a way to get hopefully as close to sort of an ideal turning radius as possible. The mathematics behind it are actually a little bit more complicated than you may sort of intuitively, or that you may sort of first think of, and that's just because, you know, the outside of the car actually has to travel further than the inside of the vehicle, and so if you think about that, what that means is that the turning radius, and therefore the amount that each wheel needs to turn, is actually different for the inside and the outside wheel, and so the linkages are. Everything is put together in such a way that hopefully we get as close to that as possible. Next slide. And then the braking system, I think that's fairly straightforward. Unlike the steering and suspension systems, it's not just a series of linkages. There's obviously a pedal that you press down, and then that pedal is essentially pressurizing a hose, a hydraulic hose, and that hose is then allowing these calipers to clamp down on the brake disc, and that slows down the car. It's fairly straightforward, but again, you know, there's some math that goes into that, ensuring that you're going to be able to push down on the braking pedal with enough force to stop the car, ensuring that the brake calipers are suitably sized to stop the vehicle. So, but yeah, that pretty much sums up dynamics. There's not a lot more to go into, I think. I'm not actually sure what the next slide is. We could have a peek. Okay, yeah, here's just kind of, this here's a picture of, on the right, this is our steering and suspension assembly, kind of without the chassis or anything, shown in this enclosed in the aero body. You can see there's a lot of components. A lot of these, basically all of the larger components that you see here are components that we've designed ourselves. And then there's also designed ourselves and then had machined, or designed ourselves and then some things are made of tubes that we've purchased. And then some of the smaller components, all the fasteners and everything we've purchased. But for the most part, it's entirely custom designed by people here on the team. And as you can see, it's a fairly complex assembly. There's a lot to put together. So yeah, we still actually do have a few parts that are being made, although the design and everything is complete. And then yeah, we're basically finalizing all of our plans and putting everything together. There's still some small on-site tasks, the pre-assembly tasks that I mentioned earlier. So there may be some small machining tasks, some welding jigs that need to be made. What do I mean by welding jigs? I mean that some of the parts are, before they get assembled into the dynamic system, there are actually several parts that need to be welded together, and they need to be welded together in such a way that ensures that we maintain a very, very tight tolerance on their geometry. And so we have built essentially these welding jigs that allow all the parts to be positioned together properly during the welding process, so that we maintain that geometry. And so putting together those welding jigs will be something that needs to happen this term, and then actually welding. We don't actually weld the parts ourselves, but getting those welded. And then press fits. So some of our parts are press fit together. That essentially means that, you know, if you have a shaft and you have a hole, if you make your shaft slightly larger than your hole, you can sort of get a very, very large amount of friction when you push those parts together, and then they're going to stay together without any kind of fastening. So mostly for us, that's done for some of our bearings that need to be, some of our bearings that, you know, they're encased essentially in a part to allow that part to rotate very smoothly, and that is a press fit. And then we have a few other components as well that are press fit, and so those things we can do in-house ourselves. Yeah, so that's the kind of stuff that you would be working on, helping out with dynamics. Are there any questions? I don't know, we can maybe give it like a couple minutes and then move on to structure or something, if that's next.
Maybe we're gonna have to solve for time. I think Min's running a bit late. He might make it exactly 10:20.
Okay, all right, all right.
Oh, you have a question?
How many people are on the sub team? Loosely defined, like, I don't know. We don't really have like an exact roster. I'd say usually on a term, for the past little while, once sort of like the major design phase is over, we've had sort of like 5 to 6 people who have helped out during the term, maybe a bit more than that. It's kind of, I think like a lot of, I guess what we're looking for, you know, you can drop in and just kind of take on a very specific small thing. A lot of the pre-assembly tasks are very self-contained, and so yeah, in the past little while, we've sort of had people kind of drop in, do a small thing, and then go out. Yeah. will the majority of people be able to make it into the shop? If not, what will the online work and learning look like? So yeah, I think if you're looking to take on a lot of sort of online work, I don't know if Dynamics really is necessarily the best place to go looking this term, just because we have completed a lot of our design work and stuff, and yeah, it may not be the best place to go looking, just because we don't have a lot of that work left to do. Yeah, sorry. I'm not going to answer the general question. I don't know. I could, I guess, but maybe I'll leave that to Catherine. I'll answer, what does the end-to-end workflow of designing the dynamic system look like? So when we started designing the dynamic system a few years ago, we started off essentially with first there was like sort of a lot of math involved. So we're given loading conditions by the competition. So we need to design to a certain amount of cornering force and whatnot. And then you sort of go from there. And then we started designing essentially just the geometry of the suspension system. So just lines in three-dimensional space connecting, where is this suspension need to go here to get to, we have our wheel here, we have our steering wheel here. How do we need to connect that through the geometry of the vehicle? And then slowly basically taking those nodes and taking all that line geometry and fleshing out components around that. And then doing finite element analysis simulation to test for impact loads and stuff. But able to join, yeah, no experience necessary. Where's the shop and is there a schedule? Maybe Catherine can answer that.
Sweet, thanks, Leif. So actually, before I go into the questions, how online work and learning look like, Dynamics is part of the mechanical general onboarding training. That's so true. even if you're looking to join any of the mechanical sub teams, with the exception of Battery Box, Battery Box has its own training on top of the general onboarding training. Join the general onboarding training because you're going to learn a lot of the basics of mechanical engineering, especially if you haven't really delved into it or if you're not in the program. And especially for those first years right now, there's some stuff you're going to be learning now that you won't be learning until maybe later this term, I believe. So yeah, join us for the mechanical onboarding, and then we'll see, we're going to start releasing tasks and what they're going to look like for you guys to sign up, or maybe reach out to leads to see if there's any tasks that you can do right away. This is more of a general question. How do people work on a team during co-op terms? So previously, before the pandemic, we actually had co-op engagement in terms of they would just kind of call in remotely or to work on stuff remote. But now it's all the same, right? If you're on co-op, and because all our meetings are online anyways, you're able to join those meetings as long as it fits in your schedule and as long as it doesn't interfere with work. Most of our meetings happen in evening in Eastern time and on the weekends, Saturday, not Sunday. So yeah, you'd be able to work remotely. If you're in Waterloo too, you can help. You can drop by in the Bay if you have new projects to work on in person. Oh, thanks, Michael, for answering part of that too. Where is the shop and schedule of when we can drop in? So if you guys were here for the first general, we kind of talked about some safety training items that you guys need to get through before even going to the shop. We are located, I don't know if we can pull up a map right now. If you guys haven't been to Waterloo, we're located in E5. Is it 1002? The first floor, right? Do you guys remember? Yeah, something in that area. Oh, it's been a while since I've been back and checked the numbers. So actually, if you are going in the Bay anyways, so you aren't. The thing is, you aren't really allowed to go in unless you sign up for a slot, and that's all in the safety training information I released in the first general. I will post that too if we have a lot of questions about where to find that safety training. So in order to go there, you have to go and get safety training, sign up for a slot, and then you go into the shop to do work or work on projects, etc. In terms of if there's a schedule of when we can drop in, Douglas, are you talking more about what task or working sessions there are, or just like the sign up sheet or something of when you can drop in. Douglas? Oh, you're looking for a sign up sheet. If you want to mute yourself, maybe we can clarify a bit so everyone else knows what knows the answer. Oh, when you'll know to come in. Well, like you can come in at any time. The thing is, as long as you sign up for like a slot. The thing, if you're coming in, you don't really know what to do. The thing is, you want to arrange with a lead or a core member first of the sub team. Ask them about the project, and then maybe select the time that works for everyone to go into the bay and start working, or select the time on yourself if you don't really need a tutorial on anything. Does that answer your question? Awesome. And Forrest asked, do you know when the safety course will be made available? I'm not entirely sure. Is it still not up on Learn right now? Okay, I'm gonna talk to the administration and see if they can re-release the safety training course. Yeah, otherwise just do the other safety training documents, such as reading through the entire safety manual, knowing the rules of working on site, attending any sessions or any extra documents regarding what the rules are and how to engage on site. That's really the only thing I can tell you until we figure out what's going on with the safety course right now. Sorry about that. Alrighty, any other questions? Okay, sweet. Thank you so much, Leif, for presenting about dynamics. We're looking forward to lots of dynamics work this term. If everyone is interested, or people are interested in joining and helping out with assembly and pre-assembly tasks.
Yeah, look forward to seeing some people in person. Yeah. No, you don't need to stick to specific subgroups. You can move around between sub-teams quite fluidly on this team. Yeah.
Alrighty, let's move on then. Oh, general next steps. Oops, I forgot about this. Remember, links to communication channels is join at www.uwmidnightsun.com that join us. Ignore the Slack channel. Just join mechanical channel, and we'll direct you to the respective channels where work is going to be happening. And if you're interested in learning more about and reading more about the car, this is a link. It's all going to be shared. The slides are going to be shared after the presentation. This is a link to a Confluence page as in documentation. Next slide. Sub-team meetings. I need to remember this. Wednesday, Dynamics is in the same meeting as Structure, so they're meeting at 8 p.m. on Wednesday. It's going to be a Zoom link that's sent to the mechanical channel. On Saturdays, it's going to be another check-in as well. It's going to happen at 1 p.m. on Saturdays, same channel, mechanical channel. Next slide. This has not been updated. It's 11:30 a.m., not 4 p.m. Next slide. All right, we're going into Structures 101. I believe Min, Michael, and Mohammed are here, so I'm going to let you guys take it away. I don't think we can hear you yet.
Double muted myself again.
There we go.
Yeah, my name is Min. I finished my 2B mechatronics. I'm the aero lead, the aero body lead, so one half of Structures. I'll let the other people introduce themselves as well.
Hi, I'm Michael. I'm also the aero body assistant lead, and I work with Min a lot. I'm in I'm into a 2A nanotech engineering, and yeah, I've been on the team since last year.
Unfortunately, our other leads could not make it. So Tommy's one of our structures leads. Kimberly is our chassis and aero chassis lead. Mohammed and Jensen, do you guys want to introduce yourselves as well?
Sure. So I'm Mohammed. I'm currently a 2A mechatronics student. I'm here helping out with a few chassis and aero body tasks, and we'll get to know a bit more about them later in this slide.
Hi, my name's Yanshan. I didn't really see these slides till today, so I didn't add my profile yet, but I'm in 2A mech and I'm the assistant PM for structures.
Cool. I think we're good for that. Sorry. Okay. So I think we've mentioned this briefly at the first general, but we'll go over it again. So structures is basically everything on the car that doesn't move, and it's broken down into two parts: the aero body and the chassis. And so I, myself, am the lead of the aero body, and so I'll give you a rundown of what it is. I think the pictures do it pretty good justice. It's basically the entire exterior of the car. Now the design of the actual aero body was a big focus of MS-14 as a whole. Like, it was like a kind of a constraint for the rest of the car, because we wanted it to be as aerodynamically efficient as possible. Now, I unfortunately was not on the team when that design was being carried out. That's one generation above me. So they finalized the design using a bunch of CFD and basically or computational fluid dynamics and just iterating through designs. Yeah, so I'm in charge of the actual manufacturing side of it. So this entire aero body is created using composites manufacturing, or made using composites. And it's either the body panel, like all of the panels on the car, except for the clear panels, are all made from carbon fiber sandwich panels. And then the clear panels are just made from thermoforming. Yeah, next slide. Am I talking about this as well, Catherine?
Sorry, I just stepped out for a bit. If you don't mind, kind of just briefing over chassis as well.
Okay, I will try my best.
I'll help you, don't worry.
If I say anything wrong or stupid, just cut me off. The chassis, structural like skeleton of the car. It's basically what handles all of the loading in the car. So the governing body / organizers, ASC, like the American Solar Challenge, basically gives us a list of criteria in terms of what our car needs to be able to handle for it to be considered safe for us to be able to put people in it. And so the chassis is what's responsible for absorbing all of those impacts and keeping our passengers safe. As well, it's also the like the mounting point for pretty much every assembly at this point. So all of the dynamic stuff is all mounted on there. All of the aero body panels are pretty much all also mounted onto the chassis, which I think Mohammed will be talking about later. Yeah, and this whole thing is, unfortunately, we didn't get to put the picture of it in this slide, but it was in the general, like the first general. The full thing is welded and sitting in our bay area right now, so it's pretty cool. Did I do good? Next slide.
Awesome. Just before we move on from chassis, just want to add some more information, but you did great. Thanks, Lynn. So this is actually called a space from chassis. Do you mind going back, Colby? This is actually called a space frame chassis. So those that are interested in motorsports or like Formula One, like it's mainly made out of steel or aluminum, the tube itself. Ours is actually made out of steel, and it's meant to support like all the loads, different loads in the vehicle, such as like the suspension, driver, aerodynamics, not motors because we don't have a motor. Sorry, not motor. We don't have an engine in the vehicle, and everything else that's supposed to mount on this. And yeah, it's. Oh yeah, like Min said, we don't have a picture of it, the current one right now, but yeah, just to put some technical names to it, it is the space frame chassis. There's another one called a monocoque chassis. That's mainly the carbon fiber version. Previously, there has been designs where we had like a bottom panel mounted to the chassis itself as like a kind of hybrid monocoque and space frame chassis. Okay, moving on.
Cool. I think this slide is pretty similar to the first general. I think it just goes over our term goals. So the big ones on the aero side are we want to learn and master resin infusion, which for those of you that were at the general I mentioned, manufacturing research, I think was what I called it. But basically resin infusion is like a separate technique that Michael will talk more about. That's more cost friendly and a lot more student team friendly for us. And so it's kind of a priority for us to learn it and master it because we're going to be using it to create the rest of the car. As well, I'm going to be working and chugging along for the manufacturing of the roof, hood, and trunk panel, as well as the bridges. I don't have pictures of the bridges, unfortunately, but I think the roof, hood, and trunk are pretty self-explanatory, but there will be pictures later. Not sure how accurate complete material testing is because I think that's been put on the back burner. But regardless, I think there has been work done for it. Yeah, I think projects and term goals are pretty similar, but most of the stuff that we work on primarily revolve composites manufacturing and how we can make it better, as well as the chassis side. There's more mechanical design, and I think maybe some FEA. Maybe Mohammed will dive into it more deeply, but I'm not 100% sure. Next slide. Ooh. Our goal, rolling chassis. Yeah, I think that is our term goal. Basically what it is we have the, Catherine mentioned the bottom panel, which is that giant like channel thing underneath the chassis. So we want the bottom panel integrated with the chassis, as well as all of the dynamic stuff mounted onto the chassis so that you can just kind of roll around this big boat looking thing. Yeah. Cool. All right, I think this is Michael's slide, so I'll let him talk.
I made updates to this. Oh, it's sad. All right, I'll just look at the updated one on my side. So I'll be taking care of resin infusion for the term and probably longer. So our term goal isn't correct here, but the term goal here is to finish testing the infusion process and mastering it, and then start manufacturing it for real parts that will go on the car, such as the roof and trunk. So the project steps are still the same. We're still researching and documenting how to get better at the process, because right now we have done a couple test pieces, but now we're looking into starting bigger test pieces with more complex surfaces to see how that process will go. So we're still in that first step as well. That kind of will be an ongoing thing throughout the entire project. So for the next car, they will know what to do when we all leave. 2, manufacturing plan. Min and I are working on that, where we will again decide which pieces on the car will be used for resin infusion and which have the best outcome for success. And then 3, which is kind of what's going on right now, we're doing test pieces. Currently, I'm in the process of making a prototype car hood as a test piece for infusion. So that'll be one of the big on-site learning tasks for infusion going forward. And then for roof and hood panel, which you can see are the blue panels in the right side of the picture. That's what we're looking to try Infusion for the real car. So as you can see in the bottom left, this is kind of our typical Infusion setup, where before in pre-preg, that's how we used to manufacture. That was where resin is already infused into the carbon fiber, but through the infusion process, we are pulling resin through our carbon fiber itself, ourselves. So we basically have, let's say, the white line on the right side, that will be our resin line, and then our black one on the left is our vacuum. So we basically have to pull vacuum on our part, which means we're going to remove all the air from the part. So we have a good place for the resin to set within our part. And once we open up our infusion, our resin line, basically the vacuum will pull the resin from the resin line and pull it across the part. And then once the resin is fully pulled through the part, we close off both lines, and then we let it sit there for 24 hours. And 24-hour cure cycle will just let the part set and give it its structural properties that we're looking for. So we're still in the process of mastering that. It gets a little complicated when we have a larger part, then we get into multiple inlets and outlets. So definitely, if you're interested in learning a new composites manufacturing technique, reach out to me, and we can definitely get started and do some more research on that.
Yeah, and I don't know if I forgot to mention this, if it was like implied, but the majority of Aerobody's work this term will be on site. So if you guys are in Waterloo, looking to get your hands dirty, make new friends, we're always here for that. Reach out to MEC on site. I'm not sure what the procedure is, Catherine.
We haven't actually posted the Mech on site channel in Mechanical, so maybe tonight I'll kind of create like a summary post of all of the stuff going on, and we can start funneling people into those channels, and plus safety training and all that fun stuff.
Okay, cool. If you guys are in Waterloo, just keep an eye out on the Mechanical channel. I guess everybody keep an eye out on the Mechanical channel. But yeah, I digress. Right, so the half of Aerobody that I'm going to be taking care of is just the general manufacturing, and what that entails is for every part you need to make a mold. Yeah. So the carbon fiber is just like a sheet of fabric. Regardless of what method you use, it's ultimately just a sheet. It's basically like a cloth almost, and you need to make the shape that you want, right? And so we have to, we design and manufacture all of our molds in-house, and that takes quite a lot of work. I've put down a little kind of like bullet point of what that would look like. We basically start with creating like a quote-unquote blank mold, which is just a bunch of like pieces of MDF, which is like a wood or foam that we just like glue together into layers, so that it's big enough. And then we machine it down in a CNC, either in-house or sponsored, and then we have to do surface finishing to basically ensure that the surface is very glossy and pretty, because we don't want kind of imperfections on the actual part itself, like on the exterior of the car. And then the layup itself, we basically prep all of the carbon fiber to size, as well as any other material that we need. So a lot of vacuum bagging stuff, core materials. We'll probably get more in depth into it at another time. But just to give you an idea, there's a lot of like material prep, just getting everything ready to put it down onto the mold. And then there's the actual layup itself where we put it onto the mold and cure it. Now, the picture on the left, or on the right, sorry, I stole it from Michael, so sorry, Michael. But the picture shows the roof and the trunk. As well, the trunk is, or sorry, the roof and the hood. The hood is that small blue sliver on the front. The trunk is behind the roof. The bridges are like, they basically sit underneath the intersection of any of these panels to support them. So if you imagine like the trunk, like this is the trunk, and then you have the roof here, the bridge will sit like underneath it to support it basically. And so we have like our goals in terms of finishing the panels are the roof, trunk, hood, and it should say 4 out of 6 bridges. I probably just
Min, I think you muted yourself, or someone muted you.
I was talking that whole time and I was muted.
Oh
That
no,
is
like
so-
literally the last 2 seconds. 2 seconds.
Oh,
Like after the four out of 7 6 bridges. That's where you cut off.
oh, well, okay. I have no idea how that happened. I don't like Teams. Yeah, but that's pretty much it for the slide, to be honest. I guess it's good timing. Should I answer that question right now or later?
How many slides do you guys have left?
Wait,
One.
you don't need to talk about this.
'Cause
Oh,
we're-
Yeah, you can view message.
Sorry?
You can answer in the chat.
Oh, okay, cool. Dope, I'll do that.
I don't think we need to save this slide because it's basically finished.
All right, I guess I'll take over for this one. So for one of the main tasks we are working on here at Structures is our Aero chassis integration task. And pretty much as the name entails, we're trying to implement our aero body to our chassis. So any of the composite panels, such as the roof, the trunk, the side panels, we got to make sure that they're mounted to the chassis somehow. And that task is one of the major ones. And so taking on a task like this, it begins by researching concepts, finding fasteners. So you can see a few images of some of the fasteners we considered to mount the roof panel on, and going through the CAD design to propose some mounts. And after we design some mounts, we have to go through a little bit of calculations in FEA. So FEA is a term you guys will be hearing often. It's pretty much just performing a little bit of analysis on the mounts or any structural component that's going to be added to our car to make sure that it doesn't break down. For example, let's say we're driving down the highway. We don't want the roof panel to just come flying off as we're driving. It's not a fun thing. And so we got to validate and make sure everything's good to go. After we have our pretty much design set, we go through our manufacturing plan, setting up jigs and designing any other components. As for a term goal for this task, we're looking to finish up prep work for the roof panel, the bridges, and the windshield. We're also looking into ordering materials and finalizing designs to have all that stuff ready to put all the panels onto the car by winter 2022, I believe. And I believe that was pretty much the overarching theme for this task. And I think that was it.
Do I get this or does Catherine get this? Because I don't really know what's going on this slide.
This is my fault. I forgot to take the slide out. Everything's relevant except for the join Slack portion. So join our communication channels. We mentioned this in Dynamics as well. It's everything like Confluence, Slack. You can all access this through www.uwsvitsun.com/join us. In terms of Slack, just join the mechanical sub-team channel. So just like # mechanical. And lastly, if you're looking for more information or you want to get a head start on reading, feel free to just access this link. Like I mentioned before, you can read this as you would like, and also all these links are going to be posted on the slides after the sessions. Lastly, reach out to your leads; they're always willing to help and answer questions. And if you're looking for a work too, that's always a good thing to do. Next slide. Same thing again, dynamic instructors have the same check-in. There's 2 check-ins that happen 8 p.m. on Wednesdays on Zoom. The link will be sent out in Slack in the mechanical channel, and on Saturdays at 1 p.m. Next slide. This is out of date. Okay. Just come to the 11:30 a.m. session that we're running about the MEC general onboarding training. Next slide. Alrighty, battery box. Owen and Micah, you guys are up.
Okay.
Thanks so much, structures.
So hi everyone, my name is Owen and I'm going into my 2A term of mechatronics engineering. I am the battery box project manager, so I help Micah with scheduling, running check-ins, onboarding, and some technical stuff as well. I don't think Micah is here today, so I'll just briefly introduce him as well. Micah is the technical lead for battery box, and he is in his 3rd year of mechatronics. He supervises the members of the team and leads the technical side of things. Okay, next slide, please. All right, so the goals for this term are to finish pack manufacturing and testing. So our battery pack is made up of 18 battery modules, and we just recently completed them. So now we need to perform testing on them to make sure that they're up to spec. And then we're going to characterize them to determine which ones we're going to use in our pack. And after that, the team will move on to manufacturing the pack by connecting those modules together. Another goal of the term is to finish the design of the enclosures that sit nearby to the battery pack. So they hold PCBs, wiring, and fans. And as well, some of the mounts for those PCBs need to be designed this term as well. So some skills you can develop on battery box are testing, CAD, which will be used for designing the enclosures and the mounts, 3D printing, which is how we manufacture the mounts, and documentation, since it's important for us to leave some knowledge for future members. All right, the battery box is the main energy storage in the car. It gives the car energy to move, and we have about 11 kilowatt hours of energy stored in the pack. It's a lithium-ion battery pack, which comprises of 900 cells, and they're 18650 cells. We run the battery pack at a pretty high voltage of 150 volts DC, so there are a lot of safety factors to consider, and these considerations give us a safer and reliable pack. Next slide, please. Okay, so let's dissect the battery pack. At the lowest unit of energy storage, we have the cell. So our pack is 900, and we get them from vendors. Our cells are from LG. And these cells are then constructed into modules, which we have 18 of, and there are 50 cells in each module. The way that they're constructed is such that modules are put into the pack and we can remove individual modules, but not individual cells. So if a module goes bad, we can just replace it. And if a cell in a module goes bad, we'll just replace the whole module. And the pack comprises of all the modules, which makes up our 11 kilowatts of energy storage. Next slide, please. Thank you. So inside a cell, this stuff is pretty cool, but it also gets pretty complicated. So I'll just cover some of it. There are a few safety features inside of the cell. One of them is a gas release vent. So if internal pressure builds up, the vent will pop and then release some of the pressure. The cells are also certified for transport, so they're test dropped, short circuited, etc. And also they have steel casing that prevents punctures. So the point is, if cells explode, it's very likely due to mistreatment by the users rather than a manufacturing error. So we need to make sure to treat the cells right. Anyways, the general chemistry of a battery, you got a cathode and an anode, and ions move between them through a separator. This causes a charge imbalance, and it forces electrons to move through the circuit. In the case of Midnight Sun, that would be the motor and electrical system of the car. Next slide, please. All right, so what the cells are not able to protect themselves against is thermal runaway. So if the cells are damaged internally, a lot of current can go directly between the cathode and the anode. and this is called an internal short. The high current causes a lot of heat and the cell will explode. And that cell exploding will also trigger the cells next to it to heat up and then explode as well. So when the cell reaches a certain internal temperature and it surpasses its activation energy and it explodes, that's called thermal runaway. So we need to be careful in meeting manufacturer precautions and designing the pack in the safest way possible to avoid this. Another concern is that the pack is high voltage, which 150 volts, which is not safe to touch. And this is why we are designing the enclosures to cover the high voltage components. Next slide, please. Right, so batteries produce heat, and if this heat isn't dissipated, it can lead to thermal runaway. So we do testing to understand how to best design modules and packs. So for example, the thermal gradient image in the bottom left shows that the cells in the middle of the module had the highest temperature, and the center ones in particular. So this could prompt us to give more cooling space inside the modules or to rethink our fan placement. Next slide. So a term you'll hear a lot on the Battery Box team is a balanced pack. So a balanced pack is when all the cells have the same energy storage available in them. If some cells have a lower energy storage than others, they'll actually charge and discharge faster. And this leads to a lower capacity because not all the energy within the cells are used. So in the two images at the bottom, you can see that the two lower energy cells are charged faster. So that's in the left image. So the rest of the cells don't actually get fully charged. And then on the right image, when they're discharging, the two cells discharge faster, so the rest of the cells can't discharge fully. So there's a lot of energy that's still in the cells but can't be used. And this is why we test all of our cells and modules to make sure that we use the most balanced cells inside of the vehicle. Okay, so since the battery pack is comprised of a number of modules, something Battery Box needs to think about is the efficiency of our manufacturing. A few extra costs in one single build may not be much, but for our 18 modules and also the backup modules, they can add up. And not to mention, a design that can be assembled quickly is something that can save a lot of time over all of the modules. So these are points that our team considers when we choose our manufacturing processes. And we have previously used spot welding, CNC machining, water jetting, 3D printing, and laser cutting to do our manufacturing. Yeah, thanks. So yeah, that might have been information overload. I definitely felt that way when I was a first year, but if you invest some time into reading documentation, asking questions, and jumping into tasks, you'll start to piece things together pretty quick. So if you're interested in Battery Box, join our Slack channel and feel free to ask questions there. There are also some Confluence pages that go into more depth on what I talked about in this presentation. Next slide. Okay, so yeah, we have our weekly check-ins at 1 p.m. on Saturdays, and Michael will be there to answer questions about any of your tasks. There isn't one today, but we start next week. Next slide, please. Okay, yep. So this is similar to the other slides. So disregard the Slack, but you can click the links. Okay, yeah, so we also have an onboarding project, an intro project for new members, and it's meant to help new members get some background on batteries and pack design. It's about a 3-week period where we have check-ins that have a segment to help new members with the project. And yeah, if you're interested, you can click the link to that and learn some more. Thanks for listening. Okay, So how do we join the channel on Slack? I think if you're already in the team Slack on the top search bar, if you put #mech_battery_box, then it should give you an option to join. Oh wait, yeah, Catherine already answered that. Yeah, there are CAD tasks mainly for designing the mounts for the PCBs and the enclosures. And also we have some miscellaneous tasks working on the CAD assembly as well. So yeah, lots of CAD. Yeah, it's fine to have no experience. So the mechanical, there's like the mechanical onboarding, the general onboarding, and they go over CAD in that. So yeah, and then you can also ask questions to any of the leads about CAD. The current range at 150 volts, I actually don't know that off the top of my head. So I can, if you join the channel, then I can get Micah to get back to you on that. And the onboarding project. So the onboarding project, it goes through some background reading on generally designing battery packs, and the project itself is mainly just going through the process of designing a pack. Although you probably won't do that since the pack is already designed, it gives a good idea of the process that the team went through when doing the whole, doing all the pack design, and then it gives a good amount of background for just general tasks because you'll have a better understanding of the higher level design. What does the manufacturing side of battery box look like? So, I don't think I can give like a super good answer because Micah is usually the one who does the in-person side of the battery box team, but typically similar to other teams, I think it's just the lead. Like you go in at the start with the lead and they kind of cover the tasks you'll do, and then eventually you'll learn enough and then be able to go into the bay by yourself and work on certain tasks. You don't have to do both for battery box. You can just do battery box, but if you're first year or not in an Eng program, it might be useful to go to the mech onboarding as well. All right. Should we head on to the next sub-team, interiors, I think?
Sweet, thank you, Owen. Is Sheila, Ali, and Renzo here? Hey, okay. I'll let you guys take over.
Sweet, okay. Hey everybody, so this is interiors. My name is Renzo. Just finished my 3A term of mech. I guess Ali and Sheila can introduce themselves as well.
Hey guys, so my name's Ali. I'm currently in my 2B Tron. Yeah, so the slide would probably have to be updated, but I'm in 2B Tron right now. And yeah.
Hi, I'm Sheila. I'm in my 3B management term.
Slide. Okay, so our mission for interiors is basically winning on all fronts. So efficiency, reliability, and practicality. However, like all the other sub-teams here, our underlying mission is to focus on team or student development. Interiors is the newest team in Midnight Sun because past cars were only focused on either single passenger cars or two-seaters, which was involved in MS-12, the previous car, but as well that car, the interior side was not as much of a focus as it is on this car. So yeah, this team is pretty diverse. We have a lot of people from different programs, side, GBDA, Chem, Mech, and Tron, as well as management for Sheila. But yeah, on the right there, that's a really old concept of what the interior or a possible look for the interior. Next slide. All right, so what we do, so in addition to helping out or accommodating the mechanical systems, we're designing and manufacturing the inside of the car. So when you think of a consumer vehicle, anything that interacts with the passenger and the driver, so things such as seats, steering wheel, dashboard, name it. So things we consider are ergonomics, driver ventilation, as well as material selection. And as I've mentioned before, in the general, there's going to be a lot of composites manufacturing as well, because most of the sub projects are composites based for the most part. Slide. Okay, so why have an interior team? So yeah, like I said before, past solar vehicles were single-seater, and the main focus was on efficiency and basically speed. See how fast you can finish the race. With the addition of the cruiser class to the American Solar Challenge, which is at least one passenger, so 2 to 4, there's a bit more emphasis on practicality in terms of how well the car accommodates multiple passengers, just like a consumer car. So the image on the left is the previous car, MS-12, after competition, right before it was torn down, and you can see the interior is a bit messy, but that was I guess the interior that they were working with for that car, because they were in a bit of a time crunch. And the images on the right is the solar team Eindhoven from the Netherlands. And they basically been winning all the competitions. And you can see why in these images. The car is pretty stacked. And so those bottom two images are what we're trying to achieve with interiors. So making sure it doesn't look, make sure that people want to sit in the car and drive it and are comfortable doing so. Next slide. Okay, so how does interiors help the team overall? So the way the solar car is being scored during competition is you have your total score and you have these variables. And the variable that we're concerned with is practicality, which is P. And as you can see, it is a multiplier for the overall score. So that means our goal is to maximize this variable. And yeah, as you can see, Eindhoven has won 2013, 15, and 17. So yeah, next slide. And so the breakdown of this practicality is we have different sort of subcategories. So things such as cabin space and comfort, features for the passengers, ease of use, desirability, and those last two do not concern us. But since interior judging is a bit more subjective, these aren't set in stone and are up to the, I guess, discretion of the judges. So they can change the metrics that they base the practicality score on. And so if we try to have an overall functioning and aesthetic interior, then we would have a good chance of maximizing that score. Next slide. Okay. Shelley, would you want to talk about the projects?
Sure. So we kind of have two main stages, like most projects. We have what's kind of in design phase and what's kind of going in person manufacturing. So right now we're kind of proceeding. So Ollie is the lead on the dashboard team and the steering wheel. So you can kind of see some concept pieces we have for our steering wheel and our dashboard. So these two projects involve a lot of integration with our electrical team. So if you're interested in kind of both getting a design portion, but also being able to talk to the electrical team and kind of being able to work back and forth in between teams, this is a really good project to join. And then I guess our manufacturing in person will be our catamaran cover, which Renzo is in charge of. It's basically just the enclosure that holds the battery box. And it will be made of fiberglass, and I think it's mainly fiberglass outside because of the we don't want things on fire, and fiberglass is non-flammable. So we will be manufacturing using the infusion process, and then we also have seats and doors. So I'm one of the DRIs on doors. Not on doors, oh my gosh, on seats. And we'll be using carbon fiber and core and a little bit of Kevlar as well for also infusion. So the team has mainly been working on learning infusion. So if you guys are interested in coming out and kind of learning infusion and getting a good hands-on experience with composites manufacturing, we would love to see you. And then also if you want to do some design portion, we've got a lot of that too, so just let me know. Yeah, cool. I think that, yeah, there's a little video if you want to play it, yeah. So this is kind of our collaboration with the Aerobody team to learn infusion, because most of the knowledge we had on infusion kind of got lost. So we're trying to regain some of it. So we are just working on trying to figure out how to infuse panels. Yeah.
So I guess this gives everyone a better idea of what on-site will look like. Yeah, this is I believe the second test piece that Michael was talking about. And so yeah, if we can get this process down to science, then we could apply that to all the other panels pretty easily. So if you're interested in this, then and you're on site, then this would be a great hands-on experience. Slide.
Also, I guess I thought I'd add, for anyone that's not on site, or if you're working remotely or anything like that, there's a lot of CAD design, like miscellaneous tasks that you could get involved in. So right now in interiors, so I'm working with the dashboard and steering. So one of the, I guess, tasks that anyone could get involved in is the steering wheel enclosure modeling. So right now we're kind of in the prototype concept phase of that. So there's a lot of small like CAD tasks. So if you guys are new to SolidWorks or anything like that and want to like start learning, you should definitely try reaching out and join the interiors channel. So there's a lot of things even if you're remote. So yeah, we'll move on.
All right, so our toolkit basically is the same for as all the other subteams with mechanical. So we use Slack, Confluence, SolidWorks for our modeling, and then GrabCAD for sharing our 3D files. And as well, there is a Trello for some of the sub-teams of interior. Next slide, please. Cool. So next steps, just like everyone else, please add the Solar UW Midside calendar. In terms of Slack, the channel is Mech Interior, and we also have our own Confluence section. So if you'd like to take a look at that, feel free. Interiors meetings are weekly at 7:30 on Wednesday, so right after general meetings, I believe. And so, yeah, come up to those. Onboarding sessions will be happening with Mech, so if, regardless of whether you're interested with structures, interiors, Aero, I guess, you'll all be doing the Mech onboarding project. So good. This is the same slide again, so disregard. Questions?
So if there's no like apparent questions at the moment, I thought I'd just like say some of the things that I guess each of us might be working on, or what you guys could be working on this term. So feel free to ask a question at any point. But basically, so one of the things that our goals is for this term is to start our manufacturing plan for the dashboard. So like a lot of the other components in the vehicle, it's also a composite carbon fiber piece. So one of the things is starting the manufacturing plan so we can get that started once a lot of the aero body and more critical components are done. So one question is, where did you start researching the concept for the current interior design? Renzo, did you want to answer that?
Yeah, so when I joined back in fall 2019, that was basically when the interiors team was created, I guess. And so it was around that time that we were kind of looking at concepts. There is we have a Google Drive with a folder that has some sort of reference designs, but we were, yeah, I think it was back around like late 2019 that we were looking at the designs. One of the potential sort of aesthetics we were going for was sort of like a Google Home. So if you think of the Google Home product and like sort of like the gray fabric on the white, that was what we were trying to sort of emulate. Obviously, as a student team, we're limited with time, budget, resources. So we're trying to keep this interior as minimalistic as possible, just to make sure, yeah, to hit our goals and sort of not overload ourselves. I'm not sure if that fully answers the question.
Yeah. Also, just to add, like a bit on the more technical side. So basically, every component on the car is like heavily regulated by the regulations of the competition. So, for example, the proportions, like the driver, like position, like the visibility. So when designing like the concept, we're kind of designing around all those things to accommodate so that our vehicle is, can pass regulations and actually compete. So when it's not really completely like, oh, you can do anything, whatever you want. So there's a lot of like requirements that the car has to have to like pass these regulations. So we kind of have those things in mind when coming up with these concepts.
Mm-hmm. Yeah, that's actually a good point too. Any other questions? Welcome. Well, if there are no other questions, I think that's about it for interiors. Thanks for listening.
Awesome. Thanks so much. We're just gonna take a short, like, 5-minute break maybe. And Jensen and Sheila, if you guys want to use that time to, I don't know, update anything right before we head on to the onboarding project.
Yeah, for sure. I think we were actually planning on sending a separate link to a different meeting for our intro session. And yeah, so I guess this slide has not been updated as you see, but we will, yeah, we'll send that out in the Slack channel. So for all new members, yeah, who want to do the Mech General onboarding project, which is kind of different than the battery box onboarding project that Owen described earlier. This is kind of more relevant to all sub-teams. And so, yeah, if you guys want to join that, Sheila will be sending that link out soon.
Awesome then. We'll just let everyone, or I guess we'll just keep this open for another like 2-3 minutes. If anyone has any general questions or just questions about mechanical, questions about the team, some of our leads are still here. So yeah. Any questions at all about the race? About the team? Hey Heather, when will what take place?